All right, I'm going to go through the Punnett squares for Prader-Willi and Angelman syndrome. This is the Prader-Willi syndrome Punnett square for two people who are having children together, an XX person and an XY person. The XX person has one wild-type Prader-Willi allele and one diseased allele. And the XY person has two wild-type Prader-Willi alleles. Prader-Willi gene is only active from the XY parent-derived or paternal chromosome. Okay, so let's see what the possibilities are for the offspring in these between these two people. We can have offspring that have two wild-type alleles, one from the XY parent, one from the XX parent. The one that will be active is this one. This one will be silent. Same thing here. This allele will be active, this one will be silent. Over here we have heterozygotes technically for this, but there is no heterozygosity for Prader-Willi really, because in this person only this allele will be active, this one will be silent. And the same thing here. Active allele, silent allele. So none of the offspring in this coupling will have the Prader-Willi disease. However, two of the offspring will be able to pass it on to other people. We can't know from this Punnett square whether these people will have Prader-Willi, children with Prader-Willi disease, because we don't know the XY genotypes of these two people. If they were XY people, they could pass it on to their offspring. But if they're XX people, they can't. Another thing to think about is this person. We're going to assume that this person does not have Prader-Willi syndrome. So think about which parent did this allele come from for this person. And it must have come from her XX parent. Okay? Okay, let's go to Angelman syndrome now. All right, this is the Angelman Punnett square of exactly the same genetic scenario set up here, where I have XY parent has two wild-type Angelman syndrome alleles, so the wild-type gene for the gene that causes that disease, and the XX parent is technically genetically heterozygous. They have one wild-type and one disease allele. In this case, Angelman gene is only expressed from the XX-derived parent's chromosome. Okay, so let's look at what's going to happen here. We can have two wild-type alleles in the next generation. In this case, only this allele will be expressed. This one will be silenced. And we can have the same thing here. Right? Again, only the XX-derived allele will be expressed. The XY-derived allele will be silenced. Or we can have this. And now we have only this allele being expressed. This allele is silenced. This is a disease phenotype. And the same thing here. Disease phenotype. As we silence the XY-derived wild-type allele, and we're left only with the disease allele from the XX parent. Again, think about this. This person presumably does not have the disease, Angelman syndrome. We're just going to stipulate that they don't. So in that case, where did their disease allele come from? Which parent? And it must have come from their XY parent, because it's being suppressed. Okay?